symmetry, but we're going to go through a little bit about what it means for functions to be odd and even. And we maybe have alluded to this idea before. But basically one of the things you want to get clear on is what this mathematical definition is. And a lot of times students understand the symmetry on this, but don't understand the definition very much. So what this says is a function's even if f of negative x equals f of x. What that really means, this is a good note to write to yourself. It just means when x is opposite, you have an opposite x, that just means you get the same y. Now that gives a certain type of symmetry. Okay, so that's what that's saying. If you plug in the opposite of x, you will still get the same y value. That isn't going to change. And then an odd function works like this. It says if f of x is equal to negative x, I can't talk, negative f of x, what this really means, and this is good to write down, just means if you have an opposite x, then what happens is you get the opposite y. And that again gives you a type of symmetry. A lot of times students confuse odd and even with symmetry, okay? But symmetry is certainly a part of that. So here's kind of the idea. This is what an even function looks like. Basically the idea is something like a parabola. If you have the opposite x, the y's are the same. Okay, that's what that means. Now how is that symmetrical? Y-axis, right? Okay. This is what an odd function looks like. If you have x, you have a function value. But if you have negative x, you have the opposite function value. How is that symmetrical? About the origin, okay? So symmetry is certainly a part of that. So the idea is this. If the function is even, then you're going to be symmetrical about the y-axis. If it's odd, you're going to be symmetrical about the origin, okay? Now, one thing you want to get real clear on this is this kind of stuff right here. Okay, so if you have an even function, if that 0.34 is an even function, then that means that when you make x opposite, y remains the same. Okay, you want to get that in your mind. Opposite x, same y. That's how that works out. So if you had a more general point, then what would happen? This would be if x becomes opposite, nothing happens to y. So that's the idea. So I want to give you a specific point, and if you graph those points, and you don't have to do this, I don't care if you do this, but the idea is if you plotted 3, 4, you would be there. If you plotted negative 3, 4, well, that would be across the y-axis, wouldn't it? That's what makes that an even function. That's the idea. Everybody okay there? When you have an opposite x, y remains the same. That's what an even function means. Every point on the graph has that feature to it, okay? Right? If you have an odd function, then it's just like some symmetry about the origin. So what happens is if x is opposite, which would now be positive 2, what happens to y? It becomes opposite also. So that means opposite x goes to opposite y, okay? And in general on this, if you had a general point xy, what would it be if it was odd? Negative x, negative y, good. Okay, so that's how that goes. You got to understand how the points work, and then that's how you'll ultimately understand what odd and even functions are. Just knowing the symmetry is not good enough. Knowing why it's symmetrical is a little bit more important. Okay, one of the things that we're going to do a lot in here is take functions and without graphing, look if they're odd or even. Okay, now this is what you basically do, is if I give you a function and you want to tell it's odd or even, you replace the x values with negative x. That's kind of like what you did on symmetry. And the idea is if it's the same as the original function, then it's even. Because what that is saying is when x is opposite, y is still the same. Okay, that's what makes it an even function. Okay, if after replacing x with negative x you get the opposite, then it's going to be an odd function. Because what that would tell you is if x is opposite, y is opposite, that's what makes it odd. Okay, and of course if neither the same or the opposite, then we just say, of course, neither odd nor even. So functions don't have to be even or odd. It's just kind of special if they are. Okay, so that's the idea. Okay, all right, you guys understand kind of what I'm talking about to start with. Okay, all right, just try in your mind even functions, opposite x, same y. Odd functions, opposite x, opposite y. Okay, if you can get that down, that'll help you understand that. Okay, all right, so we're going to start by doing just graphs. Okay, and some of your homework you'll be able to do quickly because it's just graphs. Okay, if you look at number 2, how is it symmetric? Okay, Okay, it's symmetric about the y-axis. Okay, so what does that tell you? Is it odd, even, or neither? What did I say? How quickly we forget. It's even. That's an even function. Okay, here's what it is, and I do want you to put a couple of points on there, okay? Let's say, and I'm just approximating, let's say that this point is 1.51. So it's kind of good to just throw a couple of points on here. Let's write that point as 1.51. Well, if it's even, then what does that mean? Then it means you'll have a point negative 1.51. So again, what I'm trying to get you to understand is if you have an opposite x, what's the deal with y? It's the same. That's what an even function is. Okay, that's why it has the symmetry it does. Okay, all right. The next one, how is it symmetrical? Some of you are shaking your head. No, that's good. That's a good sign. Okay, it's not symmetrical at all. Okay, so there is absolutely no symmetry on that one whatsoever. It's not symmetrical about x. It's not symmetrical about y. It's not symmetrical about the origin. So the answer is neither. Okay, it's neither odd nor even. Okay, like that. So you have to have these certain symmetries. Okay. Okay, let's look at this one. How does this one look symmetric? All you got to check is two things. Symmetric about y. Is it symmetric about y?
No.
No. Y, no way. Okay, how about the origin?
Yes.
Yes, okay, good. I think you guys are starting to get that better. Just if you fold over y, that thing right there would be like that, right? And if you fold over x, it would match. Okay, like that. Okay, let's put a couple of points on here. Okay, this is just always good to do. That's a 0.11. So that should transfer to -1, -1. Again, what that means, when you have an opposite x, you also have an opposite y. So that one would be an odd function. And again, the reason for that is just it's symmetrical about the origin. That's how that works out. Everybody with me? Okay. All right. So you want to be able to understand the symmetry, and then that will help you to understand whether it's even or odd. Okay. Let's do one more like that, and then I definitely want to go through how you do the test. Okay. How about this one? Even, odd, or neither, just by looking. Even. How come? Yeah, this is symmetric about y-axis. Okay, so that's the idea. Okay, that's what you look for, is you look at symmetry to tell if something's odd or even. Okay? All right. Now the next thing I want to look at, this is the part that a lot of times students don't write their steps on, like on test 12. So you got to be able to write your steps in such a way that I can tell you understand how to do the problem. Now we're not going to graph or anything, but this is basically what you do. First thing I like you to do is just write down the function, whatever I gave you. Okay, that's -9 x to the second minus 6. The next thing you always do, what you always do to test for something odd or even, is you let x be -x. Okay, so we're going to do that. We're going to plug in, everywhere we see an x, we're going to plug in a -x. Now we're going to see if there's three things that are possible. Either you're going to get the same original function back, or it's going to be opposite, or it's going to be neither of the two. What's going to happen on this one? It's going to go back to the same, right? Because this piece right here just goes back to x squared. So we've done this kind of stuff before. So that's -9x squared minus 6. So that means it's back to f of x. I like you to write it like that, so you're showing me that f of -x is equal to f of x, and that's what makes it an even function. Opposite x gave same y. That's the idea. Okay, so you're always going to do that on that, and just kind of compare that function to the original like that. Does that make sense to everybody? So what you did is you just showed me that f of -x is back to the same thing. That's what makes it even. Okay, all right. Next one. Some of these are a little tricky. I'm going to go ahead and just have you write down the original function. So that's -x to the third over 7x squared minus 3, like that. Okay. Then what we're going to do is we're going to look and see what happens if we let x be -x and throughout that function. So we're going to do -x to the third over 7 times -x squared minus 3, like that. Okay, and this kind of stuff that you're familiar with, what is this part going to be? Negative x to the third. What happens if you multiply a negative number 3 times? Still negative. So you're going to have a negative x to the third. So that's going to go to x to the third, right? Okay, everybody with me there? That's a negative, because it's the third power, times a negative is a positive. So what you're going to end up having is you're going to have positive x to the third, and then the denominator, what's it going to be? 7x squared minus 3, okay? Now, you've got to watch this one real carefully. Sometimes students don't get this one real well. Okay, let's look at compare the original to the new. Are they the same?
No.
No, okay, because that's a negative and that's not. Are they opposites? How do you know if a fraction's opposite? Like a half, what's opposite of a half? Negative 1/2. Okay, the numerator's opposite, but the denominator's the same. So those are opposites of each other, like that, okay? So that means what we would have is, since they're opposites, you have now concluded that that's equal to negative f of x. So that means it's an odd function. Now you got to write it that way. Okay, you want to get credit for that on an exam, you got to write it that way. There's no guessing. It's just show that and then show your conclusion like that. You must, okay? Everybody with me? Okay? All right. Go ahead. I'll let you guys see what you can do on number 8 and number 9, okay? Let's just kind of finish up class by doing those two. And I'll just give you a few minutes to see if you can write that out. Okay, try to write it out the correct way.